Okay, today we are going to talk about how to solve problems, word problems, which involve two right triangles. Okay? So it's going to be majority word problems, what is going to appear in your unit test. So it's going to be just examples. We are going to do 3 of them. The first example, I have a triangle with the altitude drawn, which is PR. The angle R in two triangles is 90 degrees. Angle S is 72 degrees. Side RS is 6.1. And angle Q is 38 degrees. You are supposed to find PQ given the following information, which is on the graph, on the plot. So go ahead and start doing it. I'm going to give you the solution in a second. To solve a problem like this one, I'm going to use the right triangle, PRS, okay, which is shown here, and I'm going to write the appropriate trig ratio using the angle which is 72. The angle is 72. I can use the tan of that angle, so I can write tan 72 is equal to opposite divided by adjacent. Opposite to angle, which is 72, is PR, divided by adjacent, which is 6.1 centimeter. Now, this one is really tan 72 over 1, so if I crisscross here, I'm going to get PR is equal to 6.1 tan 72. If you simplify this one, you get PR is about 18.8 centimeter. Sorry? Yeah. So that's going to be your PR. Now I'm going to use the value for PR, the angle 38, and I'm going to find PQ. Now in the left triangle, this one, I know the angle 38 is given. I know the opposite side is also given because I just found PQ. So I can use the sine of angle Q to find the hypotenuse of this left triangle. So I'm going to write sine 38 is equal to opposite, which is PR, and I mean PQ, which we just found to be 18.8. The side in front of angle 38 is PR, which we found to be 18.8, divided by hypotenuse, which is PQ. Now again, this is a fraction. We can just use crisscross or cross multiplication. I get 18.8 times 1, which is 18.8, is equal to PQ sine 38. Then I divide both sides by sine 38. And I'm going to get PQ is 18.8 divided by sine 38, which is about 30.5 centimeter. Now, to solve the problem to find ST, okay, what I'm going to do is that I'm going to find the angle here, which is angle SUT. And since I know that VU is 15 meters, okay, I can tell you that easily that UT has to be 25 meters, okay? Knowing UT and also the angle that I will find later on, I can use the tan ratio for this angle to find ST. But this is the process that I'm going to go through. Now, to find this angle U, I know this angle. So if I can find the angle VUW, then I can find the angle SUT easily. So let's see how can I find the angle WUV. To find this angle WUV, I know the adjacent side is 15 meters, and the hypotenuse is 21. So I can use the cos ratio to find the angle WUV. So I can write that cos of angle WUV, cos of this angle, is equal to adjacent, which is going to be 15 over hypotenuse, which is 21. If you solve this one for angle WUV using the inverse cos on your calculator, you get that this angle is 44.4 degrees. Now that I know the angle WUV is 44.4, I know angle VUT is a straight angle, which is 180. So I can subtract 115 and 44.4 to get angle SUT. So I can say SUT, the angle SUT, is 180 degrees minus 44.4 minus 115. If you do the calculation, you get this angle is equal to 20.6 degrees. So we know that this angle here is 20.6 degrees. Now, I know the angle here, 20.6 degrees. I know the side adjacent, which is VT, which is 40 minus 15, which is 25. So I can use the trig ratios to find ST. Which trig ratios is very easy because I know the angle, I know the adjacent, which is 25, and I have to find the opposite, so it's going to be the tan. So I'm going to write tan 20.6 is equal to ST over 40 minus 15, which I'm going to write it so you understand where we got this one, which is 25. So ST over 25. Again, the denominator is 1, so I can crisscross. I get ST is going to be equal to 25 tan 20.6, which is approximately 9.4 meters. Next question, we have a security camera which is mounted 8 meters up a wall, let's say here, and then we have 2 cars in front of it, let's say here and here. Now, what it's saying is that if the angle of depression from the camera to each one of the cars is 23 and 58, how far apart are they? So how much is this distance here, x? Now, by definition, angle of depression is the angle your eyesight makes with the horizon. So just by looking at this one, you can easily see that the smaller angle, which is here, has to be 23. And the bigger angle, which is this guy, has to be 58. Now, using the Z pattern, if you look here, this is a Z pattern here. Automatically, I can say that this is 23. And the same way, if you look at the graph like this one again is a Z pattern, so this is 58. We know that the height above the ground for the camera is 8 meters. So I can go ahead and use the tan ratio to find, let's say, AB and also BC here. How do I go about solving this one? I'm going to say in the big triangle, this one, I'm going to write tan 23 is equal to opposite, which is this guy, which is 8 divided by the adjacent, which is AB. Now, crisscross, you get AB is equal to 8 divided by tan 23. This is my AB. Now I'm going to go and do the same thing for the smaller triangle, which is this triangle. I'm going to write tan 58 is equal to opposite, which is 8, divided by adjacent, which is BC. So crisscross and then divide by tan 58, I get that BC is equal to 8 divided by tan 58. Now, AB, if you simplify 8 divided by tan 23, you get about 18.8. So this is about 18.8 meters. And BC, when you do that division, you get about 5 meters. Now, you can see easily that X, AC, is the difference between 18.8 and 5 meters. So you say that AC, the distance between the cars, which is X, is equal to 18.8 minus 5, which is 13.8 meters.